Welcome to Trinath chemistry classes. In this live stream video, I am going to discuss about the atomic structure in JE mains, Eamcet, Eapcet, and Neet point of view. So, tentatively, this chapter in every competitive exam, one or two bits there is a chance to ask questions from this atomic structure topic. సో ఈ వీడియోలో మనం టాపిక్ బై టాపిక్ అసలు ఏం టాపిక్ ఏంటి ఆ టాపిక్ గురించి బ్రీఫ్గా ఒకసారి మనం చూసి ఆ టాపిక్ మీద బిట్స్ ఎలా అడుగుతారో అన్నది డిస్కస్ చేద్దాం. రైట్. సో ఇక్కడ ఈ అటామిక్ స్ట్రక్చర్ మనకి అసలు మ్యాటర్ అంటే వాట్ ఈస్ ద మ్యాటర్? Matter is anything which has mass and which occupies space. Which occupies space is called matter. Which occupies space is called matter. And matter consists of anything matter. Different matters behaves differently. So in order to know about the matter, what we have to know is we have to know about what is made of matter. మ్యాటర్ దేని చేత తయారు చేయబడింది. సో దీనికి ఈ మ్యాటర్ మీద గ్రీక్ ఫిలాసఫర్ స్టడీ చేసండి వాట్ ఇస్ ద ఆటమ్ ఇస్ ది స్మాలెస్ట్ పార్టికల్ విచ్ ఈస్ ఇండివిజిబుల్ పార్టికల్ ఆఫ్ ది మ్యాటర్. ఆటమ్ ఇస్ ది ఇండివిజిబుల్ పార్టికల్ ఆఫ్ ది మ్యాటర్. మ్యాటర్ విచ్ హ్యాస్ మాస్ అండ్ విచ్ ఆక్యుపై స్పేస్. అండ్ in order to know about the matter we need to know about the atom. So according to this, the first and foremost theory proposed in order for the regarding atoms is Dalton's atomic theory. According to Dalton's atomic theory, Dalton's atomic theory, atom is the smallest subatomic particle. Atom is the smallest subatomic particle. Smallest particle of the matter and is indivisible. You see, if you are keep on cutting out the matter, the smallest indivisible particle of the matter, what? Atom. Right here, atom consists of later on, based on the experiments, atom consists of some subatomic particles such as electrons, protons and neutrons. Based on the different experiments of scientists, it is observed that atom consists of some subatomic particles such as electron, proton and neutron. Not only these three, there are so many subatomic particles like pions, muons, mesons. So many subatomic particles are there. And we know that the electron is negatively charged particle. Electron is negatively charged particle and is represented with E. And its charge is minus 1.602 into 10 to the power of minus 19 coulombs. And its mass is 9.1 into 10 to the power of minus 31 kg. Minus 31 kg. In Daltons, it is almost equal to 0.00054 Daltons. So this is regarding electron. Electron has a mass of charge of minus 1.602 into 10 to the power of minus 19 coulombs and its mass is 9.1 into 10 to the power of minus 31 kg. If you observe the proton is represented with P. It has a charge of 1.602 into 10 to the power of minus 19 coulombs and its mass is 1.67 into 226 into 10 to the power of minus 27 kg. Minus 27 kg. In Daltons, its value is equal to 1.00727 Daltons. 7 to 7 Daltons. Whereas if you take neutron is represented with M, its charge is 0, it is a chargeless particle, and its mass is 1.67 into 493 into 10 to the power of minus 27 kg, and in Daltons 1.00 into 867 Daltons. 1.00867 Daltons. So on this subatomic particles, question may be asked like this. For example, arrange the following particles. Arrange the following particles in the increasing order of their E by M values. E by M means charge by mass ratio. Arrange the following particles in the increasing order of their E by M values. So on the subatomic particles, question may be asked like this. Arrange the following particles in the increasing order of their E by M values. For example, the particles may be given alpha particle, proton, neutron, and electron. Proton, neutron, and electron. You see, we know that alpha particle is the helium nucleus. It is represented with 2He4. See, it has a mass of 4. So its charge is, see here, as mass of alpha particle is more, its E by M value is very, very less. That is, the smallest E by M value is for alpha particle, followed by mass of neutron is more than that of the mass of proton, and moreover, you see, if we observe the charge of the neutron is 0. That's why its E by M is 0. Among proton, electron, and alpha particle, as alpha particle has a mass of 4 Daltons, its first is neutron. Neutron is E by M of neutron is less than that of alpha particle, which is less than that of proton, which is less than that of electron. You see, there may be a question may be asked like this: which of the following order is correct or incorrect? Which of the following order is correct or incorrect? You see, here the alpha particle, the neutron has the E by M value of 0, then followed by next one is alpha particle. Highest E by M value is for electron, as its charge is 1.602 into 10 to the power of minus 19, and its mass is almost 1813 times lower than that of the mass of the proton. E by M value of electron is higher, more for electron. So on subatomic particles, question may come like this. Now, next we need to know about what is atomic number and what is a mass number. What is atomic number? Atomic number is denoted with Z. Atomic number is denoted with Z. Atomic number is denoted with Z. Here, atomic number means number of electrons or protons. Number of electrons or protons present in an atom. Number of electrons or protons present in an atom. So, number of electrons or protons present in an atom. Suppose if atomic number is 6, it means the element has 6 protons and 6 electrons. So as the atom is neutral, number of protons and electrons are same. That's why if atomic number is 6, it has 6 protons and 6 electrons. If atomic number is 10, it has 10 protons and 10 electrons. If atomic number is 100, it has 100 protons and 100 electrons. Right? Here, another word is mass number. Mass number is denoted with capital A. Mass number is denoted with capital A and is the sum of the protons and neutrons. Protons and neutrons present in the atom. Sum of the protons and neutrons present in the nucleus of the atom. An atom. So generally, mass number is equal to sum of the number of protons plus number of neutrons. number of neutrons. Number of protons plus number of neutrons. You see that it is equal to the mass number is the sum of the protons and neutrons, sum of the protons and neutrons present in the nucleus of an atom. Nucleus of an atom. Here, generally, the number of neutrons are calculated. Number of neutrons are calculated by using the formula A minus Z. A minus Z. Number of neutrons are calculated by A minus Z, because A is the number of protons plus number of electrons, and Z is the number of neutrons. Z is the number of protons. The protons are cancelling. Here we are getting the number of neutrons. So number of neutrons is given by A minus Z. And we know that atom generally represented as X, and there is a Z A, or it is represented as ZXA. Here X corresponds to the symbol of the atom. And Z corresponds to the atomic number. And A corresponds to the mass number. So generally, for example, if I write this is, you see, carbon is the element symbol of the carbon is C, and this is corresponds to the atomic number of carbon is 6, and mass number of carbon is 12. See here, in this atomic number concept, we need to know certain words such as isotopes. The first word is isotopes. What are isotopes? Isotopes are the species having same atomic number, but different mass numbers. Those species we are calling them as isotopes. Isotopes are the species having same atomic number but different mass numbers. For example, if you observe carbon, you see C6, 13, 14. You see carbon has 3 isotopes, C12, C13 and C14. Here atomic numbers are same and but mass numbers are different. Here isotopes of any element have same chemical properties, but different physical and radioactive properties. And also different radioactive properties. You see, we need to remember this word. Isotopes of an element have same chemical properties. Chemical properties of that element, isotopes of that element are same, but they have different physical properties. So isotopes means the elements having same atomic number, but different mass numbers. Isotopes means the elements having same atomic number but different mass numbers are called different mass numbers are called isotopes. Isotopes of an element have same chemical properties but different physical and radioactive properties. So this is regarding isotopes. Next word is isobars. Isobars means the species having same mass number but different atomic numbers. atomic numbers are called isobars. Next word is called isobars. Isobars means the species having same mass number but different atomic numbers. Same mass number but different atomic numbers. For example, C640, 7 and 40 and 8O40. You see, these are the isobars. These are the isobars. You see, all the isobars have same physical properties, but different chemical properties. Different chemical properties. You see, isotopes, if you observe, isotopes have same chemical properties, but different physical properties. Isobars means isobars having same physical properties but exhibit different chemical properties. You see, on these points, question may be asked: which of the following is correct or which of the following is incorrect? Like this, the question may be asked. Then third one is isotones. What are isotones? Isotones means the species having same number of neutrons. Isotones means the species having same number of neutrons. Neutrons are called isotones. The species having same number of neutrons are called isotones. For example, if you take 7 and 15, 8O60, like this, if you take, these two are corresponds to the isotones, because number of neutrons here, just previously we have seen how to calculate number of neutrons. A minus Z, 15 minus 7, this is corresponds to 8. What about here? 16 minus 8, this is also 8. So as these two species are having same number of neutrons, these species together are called isotones. Isotones means the species having same number of neutrons are called isotones. Or generally isotones of any element have different atomic numbers and different mass numbers. So generally isotones of an element exhibit different physical and chemical properties. So this is corresponds to the isotones. Next word is isodiaphers. What is the next word? Isodiaphers. Isodiaphers means, what are isodiaphers? Isodiaphers means the species having same value of A minus 2Z. Having same value of A minus 2Z. Having same value of A minus 2Z is called isodiaphers. Isodiaphers means the species having same A minus Z 2Z value. A minus 2Z value is called isodiaphers. For example, if you take 2He4 and 8O60. You see, these two are having, these two species are corresponds to isodiaphers. Because what is the mass number here? Here A is 4. What is the Z? 2. What about here in this case is, here A is 16, Z is 8. Now calculate the A minus 2Z value. A minus 2Z value here 4 minus 2 into 2, here 16 minus 2 into 8. So A minus 2Z value is same for both the species. Hence, these are called isodiaphers. Isodiaphers means the species having same value of A minus 2Z. Having same A minus 2Z value, those are called isodiaphers. Here, the question may be asked like this. In objective point of view, You see, they may give set of species. They will ask which of the following pair is. Which of the following pair is isodiophers. Isodiophers. Maybe options are given like this: 6C14, 6C14 and 11A23. Then B is 12 magnesium 24, 11 sodium 23. Then C is 2He4 and 8O16. Then D is 12C6 and 7 and 50. See, question may be asked like this: which of the following pair is isotopes? Which of the following pairs is isobars? Which of the following pairs is isotones? Like this, the question may be asked. Then how to calculate? You see, here question is asked for isodiophers. Isodiophers means what? The species having same A minus 2Z value. The species having same A minus 2Z value. Those are called isodiophers. Here, isodiophers is the C is the option. Because just now we have seen 4 here 2He4 and 8O16 both are corresponds to the isodiophers. If you observe this set, option B, you see 12 magnesium 24 and 11 sodium are 23. Magnesium 24 and sodium 23. These are corresponds to the isotones. You see what are now 12 or 24 minus 12. Number of neutrons are 12. 23 minus 11 also number of neutrons 11. 12. Hence, both these species are having same number of neutrons. That's why these are corresponds to isotones. Isotones. So we have seen isotopes, isobars, diophers. Here, in objective point of view, question may be asked like this: which of the following pair is isotones, isotopes, isobars, or isodiophers? Like this, the question will be asked. The question will be asked like this. Then next topic is here isoelectronic species. Isoelectronic species. Isoelectronic species means the species having same number of electrons. Same number of electrons are called isoelectronic species. The species having same number of electrons are called isoelectronic species. For example, if you take example for the isoelectronic species is O2 minus, F minus, neon and Na plus. You see, if you observe, O2 minus means oxygen has 8 protons and 8 electrons. 8 protons and 8 electrons. O minus, how it is formed? By gaining of 1 electron. That's why O minus has 8 protons and 9 electrons. O2 minus means it has 8 protons and 10 electrons. 10 electrons. You see, negatively charged species is formed by gaining of electrons, and positively charged species is formed by losing of electrons. Here, O2 O minus is formed by gaining of 1 electron by oxygen atom. Then O2 minus, as 2 minus is there, it has accepted 2 electrons. That's why initially oxygen has 8 electrons plus 2, total 10 electrons. If you observe F, fluorine, it has 9 protons and 9 electrons. So F minus is how it will be formed? It is formed by gaining of 1 more electron. That's why there is no change in number of protons, but number of electrons 1 will be increased. And we know that neon means neon has 10 protons and 10 electrons. Similarly, Na plus, if we observe sodium has 11 protons and 11 electrons. But Na plus is formed by losing of 1 electron. That's why it has 11 protons and 10 electrons. If you observe all these species are having same number of electrons. Are having same number of electrons. That's why these are called isoelectronic species. These are called isoelectronic species. The question may be asked like this. They may give set of pairs or set of species, out of which of the following pairs are isoelectronic. Isoelectronic species means the species having same number of electrons are called isoelectronic species. And here we need to select the correct option. We need to know first its atomic number and atomic number. You see, as atomic number corresponds to number of protons and number of electrons, then negatively charged ion is formed by gaining of electrons, whereas positively charged ion is formed by losing of electrons. Negatively charged ion is formed by gaining of electrons, and positively charged ion is formed by losing of electrons. As 1 minus is there means it has accepted 1 electron. If 2 minus is there means it has accepted 2 electrons. Similarly, n minus is there means it has accepted n electrons. Similarly, positive ions are formed by losing of electrons. If 1 plus means it has lost 1 electron, 2 plus means it has lost 2 electrons, n plus means it has lost n electrons. So here, in atomic structure point of view, if they want to ask easily questions, which of the following pairs are isoelectronic, or select the isoelectronic pair among the following species. Like this, the question will be asked. So this is regarding isoelectronic species. So we have seen some 4 words. What are those? Isotopes, isobars, isotopes, isobars, isotones, isodiaphers, and isoelectronic species. Isoelectronic species. Now we need to move for the atomic models. Atomic models. Is a Rutherford's point, we are calling it as the A protons, B electrons, C neutrons, D nucleus. D nucleus.